B coefficient or coefficient B, which is a combination of permanent B and induced B. The permanent B ka the peak force, the ship's permanent magnetism, the P force, the forward aft component is what we are talking about here, that causes B. We were talking about the induced B in the last class. So we have already seen that it is caused, the induced C is caused by the vertical soft iron which is placed forward and aft. The two conditions we have seen, the compass is here, maybe there is one forward, above, or below, like this. Forward, aft, above, forward, aft, below. In these two cases, these rods will become either positive or negative, and they are going to affect the compass, creating a deviation. I think we have seen it on the diagram. How the poles are going to be created will be dependent on the hemisphere. In the south hemisphere, we know the lines of forces are coming out from the, at the pole, it is vertically coming out. And in the North Pole, geographic North Pole, it is vertically going in. So basically, the total force of the magnetic field is at an angle 90 degree at the pole, but at an angle which is the angle of dip, as we know, minus 90 at the South Pole, plus 90 at the North Pole. So based on this, whether the total force is inclined upwards or downwards, North hemisphere में downwards होगा, South hemisphere में upwards होगा. So the two components can be derived from here just by making an arrow. For North Pole, please tell me North Pole, North hemisphere में, when the ship is there, what kind of polarity will be developed in the vertical soft iron? And when in South hemisphere, what will be the polarity of the vertical soft iron? Please tell me. Let us say there is forward, there is this vertical iron which is forward of the compass. Anyway, कहाँ पे छोड़ दीजिए अभी, सिर्फ polarity की बात करते हैं. North Pole and South.
Top one will be blue and down one will be red.
In which hemisphere?
Sir, northern hemisphere.
Northern hemisphere में top will be red, bottom top will be blue, bottom will be red. Is that
red.
what you're saying?
Yes.
Okay. Okay. एक बार बोर्ड पे चल के देख लेते हैं. Right. So as we know, the lines of forces will be coming in and going out here. So this place in the North hemisphere, we can see that the total force is coming down like this, which can be resolved in H and Z, like this. If this is the vertical soft iron that we are talking about, lines of forces are created like this. So accordingly, there will be pole created. Okay? So towards this will be the red pole, and this side, the upside, will be the blue pole, like this. So you're correct. In this place where it is lifting up, actually it is going above the ground. This is above the ground, which can be resolved into like this: H and Z. If the vertical soft iron is here, The red will be towards this and the blue will be towards this. Clear? ऐसे मोहित ने तो बता ही दिया था, मोहित को तो क्लियर है. Other people, everybody clear? This we are talking about in northern hemisphere. This we are talking in southern hemisphere. This is how the pole will be developed in the vertical software. Now, if we take a look from the side view, if this is the compass here, there can be a rod like this, a rod like this, this, and this. So, effective poles are these poles which are going to be affecting the compass. At some time, this will become blue. At sometimes this will become blue, or maybe where it is there, this will become blue. Other times, this may become red, depending again on the hemisphere. So, which is the rod which is going to create induced P? What are we calling these vertical rods?
Z.
The C rod. These are vertical. These are C rods basically. That is why we are component, or maybe no, not because of that. So these are vertical rods which are called C rods, and this C rod can be either minus C or plus C. So when will this be plus and when will this be minus will depend. If forward of the shape, starboard of the shape, and below is the positive. So if we keep this one end is positive because it is forward, but the other end is above, so this becomes negative. This gives rise to a negative C, or rather negative C. Yes, of course. Same way, if there is the rod which is like this is aft of this, so this is minus, but this end is below the compass, so positive, this also becomes minus. On the other hand, if the rod is like this one is forward, so this is plus, this one is below, so this is plus, this becomes plus rod. Similarly, this also is plus rod. So minus C will be created by a rod forward and rod aft. Rod forward and above, rod aft and below. This will be, these two will be negative C, and these two will be creating positive C. Okay? So we have understood when these are going to acquire what kind of polarity. The rods, where when they are going to be induced by Z, of course, as we know, this will be induced by
Vertical component.
vertical component, the Z. The Z we know is max on pole and 0 on equator. That means the role of C or the induced B will be 0 at equator. The role of this induced iron will be 0 on equator because Z is 0. So no induction, magnetic induction in these rods at equator. This will not be present on equator, but it will be maximum towards, as you are going, it will keep on increasing towards the poles. In most cases, most cases, the funnel is the most predominant structure near the compass, which is having vertical orientation. Normally, what you have seen is the compass is forward of this. That means the funnel is behind the compass. Is that correct?
Yes, sir.
Yes, sir.
So that is the vertical soft iron, which is going to cause the trouble to the deviation to the compass. The most likely factor or vertical soft iron is going to be the funnel, which is aft of the compass. So that is just for an information. Given the induction, let us say a pole is developing at the aft of what? Aft of, एक second. A blue pole is developing at aft of this. So on these different courses, can you work out the deviation which is going to take place? Can you work out the deviations?
Yes, I will try.
Okay, please go ahead, try it.
So we'll do it for the funnel.
Everything put together. Now you have a blue pole at the aft of the compass. It is, let us say this is funnel only, but what we can note here is that this is going to be the situation in which hemisphere funnel is almost level with the compass, correct? Almost level
Yes,
with
sir.
the compass.
Yes, sir.
जो मंकी आइलैंड होता है, मंकी आइलैंड के पास में यहाँ पे फनल ऐसे होती है, तो फनल का पार्ट ये कंपास के पास होता है, which is aft of this.
Yes, sir.
So if we are saying that this is getting to blue pole, this here is becoming blue pole. So blue pole aft of the compass. Is that correct?
Yes, sir. There is northern hemisphere.
Uh, Blue pole on top. Blue pole on top. Yes, correct. Northern hemisphere. This is the case of north hemisphere. So you can see here that the compass will not be deviated because this is here, red is here. So it is going to be minimum. DF is minimum here. Correct? क्योंकि अर्थ का मैग्नेटिक फील्ड ऐसा है और इसका मैग्नेटिक फील्ड उल्टा होगा, फ्रॉम रेड to the blue, correct? So DF should be minimum. Is that correct?
Yes, sir. 90-degree opposite.
But deviation का क्या होगा?
Maximum.
Why maximum? एक फोर्स यूं लग रही है, एक फोर्स यूं लग रही है, एक कंपोनेंट इतना है, दूसरा कंपोनेंट इतना है, तो रिजल्टेंट इतना ही हो जाएगा ना। डेविएशन का क्या होगा? कोई
जीरो
इसमें
जीरो
डिस्टर्बेंस थोड़ी आ रही है, इधर को थोड़ी जा रहा है,
जीरो रहेगा।
जीरो। तो मैक्सिमम यहां होगी, जीरो यहां होगा, मैक्सिमम यहां होगा, यहाँ पे डेविएशन इज अगेन व्हेन इट इज गोइंग टू दिस साइड, यहां से पता चल जाएगा दिस ब्लू एंड and this blue end going to push, so it will be deviated to west or not?
Yes sir.
So westerly deviations maximum westerly, less deviation, and so on. So I think you can work it out now, or you want me to go through the whole of the process?
No sir, we can work. Just one question sir. In the
Yes.
east, sir,
Huh.
Z will be zero, so how this vertical iron will be induced?
No, not in east the vertical Z will be zero. It is on the equator that it will be zero.
Yes sir. Okay, yes
So
sir.
only that Z की value is going to change with latitude, not with the course.
Yes sir, okay, yeah.
मैं यहाँ पे हूँ, Z यहाँ है, Z मैं कहीं भी रहूं तो Z वैसा ही रहेगा। मैं
Yes
आगे
sir.
पीछे जाऊंगा तो ये कम ज्यादा होएगा। मैं इक्वेटर पे आ गया तो जीरो हो गया, मैं पोल की तरफ बढ़ा तो बढ़ता गया Z, बट इट डज नॉट चेंज। अगर मान लीजिए 40 डिग्री नॉर्थ लैटिट्यूड में शिप इज डूइंग लाइक दिस, वहां तो Z तो उतना ही रहेगा ना।
Yes sir, that will be same.
यस।
Yes.
सो ईस्ट का फैक्टर नहीं आ रहा है यहाँ पे। Z की वैल्यू इज नॉट अफेक्टेड बाय ईस्ट वेस्ट नॉर्थ साउथ, it is affected by the latitude at which the ship is or the compass is.
Yes sir, understood by latitude. Yes.
Okay, so did I answer your question?
Yes, I was confused with that equator and this one when it was.
No, no issue, no issue, no issue.
Sir, southeast में heading पे sir, the deviation will be easterly.
Southeast, we are going southeast. This is where you are saying the compass is here.
Southeast, sir, southeast.
Southeast, sorry. Okay. Southeast. So the compass is here.
Yes sir.
This is a blue pole and this one is the red pole. So what is going to happen?
Westerly deviation.
We have already said westerly on all these courses, from 0 to maximum to 0.
Okay.
And easterly here, because if we have the red pole here, this is going to attract it here and it will pull to this side. So easterly it will go. This will be attracted to this blue pole. ठीक है?
Yes, I understand.
All right. So now there is a vertical soft iron which is causing all this trouble to the compass. So how do we correct it? Anyway, latitude का effect समझ में आ गया है. You will work it out. At given location, the value of H and Z. H is here. The induction is happening because of Z. Z की value या तो ऊपर की तरफ होगी या नीचे की तरफ होगी, depending on the direction will be depending on the hemisphere. Upwards in the south, downwards in the north. So north hemisphere, south hemisphere में upwards होगा. And the deviation which it is going to cause will depend on that Z. So latitude के साथ जो फर्क होएगा, just 1 second. Okay, latitude का फर्क. Oh, we have already seen that latitude का फर्क कि on the equator this error will be, or deviation due to this will be 0, and as we are going north and south, increasing. There is a term which is normally used when talking about this compass, the mean directive force. Mean directive force. Now, what is the mean directive force? This term may be coming in respect of all these coefficients and some characters also. So what is the mean DF is how much of delta was here, how much here, how much here, how much here. पूरे overall movement of the compass. How was the overall change? The thing is, now in the previous case we have seen it is westerly on this side, easterly on the other side, the deviation, and it is equal and opposite on the same course in these two half circles. जितना इधर होता है यहाँ पे उतना ही इधर होता है यहाँ पे, easterly and westerly nullified. So what we say that the effect of this directive force due to which it is changing, the mean directive force remains same. जैसे अभी हमने कहा था कि यहाँ पे 0 है, यहाँ पे वेस्टर्ली है, यहाँ पे मैक्सिमम है, यहाँ पे फिर वेस्टर्ली है, कम हो गया थोड़ा, यहाँ पे 0 है. So in this, what we are saying that the directive force here is 0, directive force is reduced to minimum, then 0 again, like this it is changing. So whatever change taking place this side, opposite of that is taking place this side. So mean directive force basically is constant. कहीं पे ज्यादा होता है तो कहीं पे कम होता है, जितना ज्यादा होता है उतना कम हो जाता है. So the mean directive force in these cases that we have discussed is basically remaining same. Now what is next? Now here is your shape. Maybe Monkey Island here and the funnel here. Compass यहाँ पे रखा हुआ है. Some red and blue pole developing here depending on the hemisphere, all right. This is caused by a vertical soft iron. VSI we are calling it, vertical soft iron. If we want to nullify this, soft iron को अगर nullify करना है, so should we place a permanent magnet here somewhere?
Yes, sir.
Permanent परमानेंट मैग्नेट से इसको हम नलिफाई कर सकते हैं या नहीं? कॉमन सेंस.
Yes, sir, with opposite poles.
Very good. Opposite pole is all right, but the permanent magnet part is not correct. Why? Because this is a soft iron. कभी होगा कभी नहीं होगा. अगर हमने परमानेंट मैग्नेट यहाँ लगा दिया तो ये तो हमेशा रहेगा. फिर ये जब खत्म होगी, ये जीरो होगा, तो ये अफेक्ट करता रहेगा उल्टा. ये एक पॉजिटिव सी आ गया मेरे सामने. So what is done actually? That soft iron is corrected by another soft iron. That means जितना इंड्यूस यहाँ पे हो रहा है तो एक दूसरा इंड्यूस करा दे यहाँ पे दूसरे तरफ. तो अगर टॉप व्यू देखें हम, कंपास अगर यहाँ पे है और फनल इज समवेयर हियर, व्हाट वी डू, वी प्लेस अ सॉफ्ट आयरन फॉरवर्ड ऑफ द कंपास. तो जो ये डेवलप कर रहा होगा वैसे ही इधर को करेगा, उल्टा करेगा. लाइक फॉर लाइक, जैसे को तैसा करते हैं, इधर जितना तो उतना ही उधर. सो व्हाट वी एक्चुअली डू, that the compass binacle that we have, the funnel is here somewhere, we create or we place a vertical soft iron here called Flinders bar. This is soft iron. This is placed forward of the compass. So जो फोर्स इधर लगेगा वैसा ही फोर्स इधर को लगेगा, but it is since opposite, both of them will cancel out each other. How will they cancel out? They have to be equal also. So this bar can be smaller or can be made bigger or can be made bigger. So this is a cylindrical piece of iron, soft iron, which can be placed forward of the compass because of for nullifying the effect of the funnel. So very often when the ship is like this, if we have compass, normally in merchant ships, the compass will be located at the center line. So the pillars here, they will cancel out each other, soft iron pillars. So normally in merchant ship, this kind of situation will not be there. Forward aft wali jo hai, that will be there. Vertical irons in the athwaship direction may not be available, but this may be present. The forward aft may be present, and most likely this one is the funnel. And that is what we are doing. To compensate this, we are placing a Flinders bar at the forward. The Flinders bar is probably named after a captain who found out this problem, and solution to this, that by placing a rod like this, we can nullify some of the effect of the vertical rods. And so in his name, it is called Flinders bar. Just for an idea, if the ship is, let us say, aircraft carrier, so in that case, the accommodation will be here for the runway to be free. The compass can be offset. Here it can be very close to some pillars on this side. So there is a symmetrical soft iron on the athwarship direction. Effect of this starboard side will be more than the port. And so for that, what we can do, we can also have a Flinders bar on opposite side of the magnetic field. But that's not normally the case in the merchant ships, which are normally made asymmetrical, and the compass location is well balanced, so that the vertical soft iron on the starboard and port are balanced. The compass is in the center. How are we? How we are going? All right.
Yes, sir.
यस सर, पर सर ये फ्लिंडर्स बार को कितना ऊपर या कितना नीचे करना है वर्टिकली, तो वो किस
Okay.
चीज पे डिपेंड करेगा?
What happens if you have the compass here and the funnel is quite big? It may produce lot of effect, very strong magnet being produced. Then we may have to have a bar which is to be longer, but we cannot have longer than the back plate. If that is the case, it should be lifted up. And we want this end to be more effective to the compass. ये वाला उतना effective नहीं होगा. Like for example, this one will be effective pole. This will not be the effective pole. जो हम सारे केसेस बात कर रहे हैं, इस सारे केस में वो एंड जो कि कंपास के पास में है उसका इफेक्ट देखते हैं. अगर कंपास से हमारे पास एक रॉड ऐसा है, तो दिस वन इज नॉट टेकन इनटू अकाउंट. द इफेक्ट ऑफ दिस एंड इज काउंटेड. So normally it should be horizontal like this, but if we have to have longer, then this is kept little above. Why? Because when we are talking about the poles in the magnet, they are not necessarily, the poles are not necessarily at the end here. The poles are actually located somewhere in this area. So we want the maximum effect of this pole at the compass. So it should be kept little above. Normally, if this is L, the length of the bar is, let us say L, then it will be L by 12. This will be L by 12. मतलब 1 मीटर का है तो 1/12 मीटर के एंड से 1/12 मीटर इधर को आएगा. That means about 8 centimeters. 12/96 हो गया ना. So about 8 centimeters from the end, the poles will be existing. So इसको थोड़ा सा इससे ऊपर करके लगा सकते हैं. Are we good?
ओके.
फ्लिंडर्स बार की बात कर ही ले रहे हैं, तो एक दो प्रॉपर्टीज इसके बारे में लिख लेते हैं. प्लीज राइट डाउन. The Flinders bar specifications or specification. Flinders bar diameter 76 mm.
सर प्लीज रिपीट कर दो दोबारा से.
Yes. तो Flinders bar है हमारा 76 mm dia, cylindrical. There are different lengths, 12 inches. We have actually various kind of bars available. We can have different bars available in the shape, and we can place it as per our requirement. If we want bigger one or the smaller one, so we can choose between them. We may have to use two of them depending on situation. So we have 12 inches, or let us say mm में भी लिख देते हैं. So 305 mm, which is 12 inches. एक होता है, एक बार होता है. Then we have 152 mm, which is 6 inches. That is also one bar. Then we have 76 mm, which is 3 inches. That is also 1 bar. Then we have 38 mm, which is 1.5 inch. Yes, 1.5 inch. That is also 1. Then we have smaller ones, 19 mm, 3 by 4 inch. 3 by 4 inch. We have got 2 of them. The overall length, if you add this and this and this and this and this, all of them put together will be making something like 610 mm. So 12 6 18, 18 3 21, 1 22, 22.5, 22.5 और 1.5, 22.5 और 1.5, 24. सो 2 फुट का ये फ्लिंडर्स बार होता है, अलग अलग साइजेस में. ये तो 76 mm हो गया. एक 12 इंच का होगा, एक 6 इंच का होगा, एक 3 इंच का होगा, एक 1.5 इंच का होगा, 1.5, और छोटे छोटे 2 होंगे 19 mm के. ठीक है.
Yes.
So understand one thing, as far corrections are concerned, a simple one liner, P, Q and R, all by permanent characters. Soft iron corrected by soft iron only, or induced magnetism in soft iron corrected by soft iron only, soft iron characters. This is the standard rule. What concept wise concept clear हो जाएगा कि जो परमानेंट मैग्नेटिज्म है PQR, उसको हम करेक्ट करेंगे परमानेंट मैग्नेट से, और जो इंड्यूस्ड ईएमएफ इंड्यूस्ड मैग्नेटिज्म होती है उसको हम सॉफ्ट आयरन से करेंगे, ताकि जो इसमें क्रिएट हो वो इधर भी क्रिएट हो, लेकिन उल्टा एंड इक्वल हो, सो दैट दिस इफेक्ट इज नलिफाइड बाय द करेक्ट. सो बी के बारे में हम लोग जो देखा है हम लोगों ने, व्हाट वाज द फॉर्मूला फॉर द टोटल डेविएशन प्लीज? A plus was it B sine cos?
Sin cos plus C cos cos plus B sin 2 cos plus E cos 2
So
cos.
we are concerned right now here because we are dealing with this. Permanent PB में, did we see that it is related to sine of the course? 0 पे 0, 90 पे maximum.
Yes, sir. Sine cos.
Yes, sir.
Okay. IB के बारे में बताइए, जो अभी डायग्राम आपने बनाया, शायद खुद ही से बनाया है, उसमें कैसे चेंज हो रहा है? 0 पे मैक्सिमम, 0 पे 0, कितना डेविएशन हो रहा है अलग अलग कोर्सेज पे? यहाँ पे क्या हुआ था, एक ही तो केस लेना है, कंपास में यहाँ पे रखेंगे या यहाँ पे होंगे, तो इट विल ओनली एड अप द डायरेक्टिव फोर्स और सबट्रैक्ट द डायरेक्टिव फोर्स, बट विल इट कॉज डेविएशन?
No, sir.
So
Zero.
that is again going by the sign of the course.
Yes, sir. Sir.
That is why we say B sin course, जिसमें B में PB भी है और IB भी है, दोनों सेम इफेक्ट प्रोड्यूस करते हैं, that they are 0 at 0 course, 0 at 180 course and 90 and 270 पे मैक्सिमम, बट ऑपोजिट, एक ईस्टर्ली एक वेस्टर्ली। ठीक है, but
Yes.
the value of IB, as we were discussing, I think also depending on the latitude, क्योंकि लैटिट्यूड के साथ क्या हो रहा है, ऑन इक्वेटर H is like this, Z 0. When we go up in the latitude north, the total force is like this, there is a Z developing and there is H developing, so this can be resolved into these components. तो जैसे जैसे लैटिट्यूड बढ़ता है, ये बढ़ रही है, तो इंड्यूस्ड मैग्नेटिज्म बढ़ता जाएगा।
Yes, sir.
Induced magnetism बढ़ेगा, that means IB, so IB that we are talking about is very much dependent on this latitude. So यहाँ से what we can understand is deviation at हो सकता है ये जंपिंग करता हुआ लगे कि ये कहाँ पहुंच गए हम लोग, but delta 2 by delta 1 is sine force 2 by sine force 1 into Z2 by Z1 into H1 by H2 is equal to sine force 2 by sine force 1 into tan theta 1 by tan tan theta 1. The deviations which are caused are happening as per sign of the course, but it also varies as per the Z and H, which is opposite to each other. H बढ़ता है तो Z कम होता है, Z कम होता है, Z बढ़ता है तो H कम होता है. So this will be depending, deviation will be depending on the factors of Z as well as H, क्योंकि H is also causing anyway, here we are talking about only Z, H को छोड़ दीजिए. ठीक है, so ये नोट कर लीजिए as far as IB is concerned. Here what we are seeing, we are not seeing latitude, but we are seeing Z1, Z2, which is basically saying it is about latitude only. Latitude पे कौन सी value घटेगी बढ़ेगी, that is depending on the latitude. So although we are not writing anywhere latitude, but the factors due to latitude is already there in the in this equation. Okay, write down next. I think we have spent enough time here. Coefficient C. Let me sit down. Just 1 second. Write down definition. Coefficient C is the maximum value of coefficient C is the maximum value of the semicircular deviation which varies as the cosine of the compass course, which varies as the cosine of the compass course. Which varies as the cosine of the compass course and is caused by sorry, and is caused by the horizontal athwartship component caused by the athwartship component of the ship's magnetic field at the compass position. Component of the ship's magnetic field at the compass position. Full stop. Coefficient C is the algebraic sum of permanent C and induced C. Coefficient C is the algebraic sum of the permanent C and induced C. Next paragraph. A plus C is caused if the horizontal athwartship field at the compass acts towards starboard, acts towards starboard, and a minus C is caused if the magnetic field acts towards port. Please read it out. If anyone has missed out, please read. Have you been writing? Karanji?
Yes sir, लिख लिए.
Okay. Karan, please read.
हाँ जी sir. The coefficient C is the maximum value of semicircular deviation, which varies as the cosine of the compass course and is caused by horizontal effort shift component of ship's magnetic field of the compass position.
At the
Coefficient C,
compass position. At the compass position.
okay, sir, at the compass position. Coefficient C is the algebraic sum of permanent C and induced C. Plus C is caused if horizontal effort shift field at compass acts towards starboard, and minus C is caused if the magnetic field acts towards port.
Very good. So now we are having a horizontal rod again, but this time it is aligned athwart shape. A में हमने देखा था forward aft, B में हमने देखा vertical, C में फिर से horizontal but athwart shape. That means pole will be, effective pole will be starboard of the compass or port of the compass. The poles will have a direction, of course, running from red pole to south, blue pole outside, and the compass is naturally outside the magnet only. So the field will have a direction either this side, going from starboard to port, or from port to starboard. So the causes of C, the poles, the red and blue pole, can acquire this kind of situations, what we are going to see once again on the board. So going to the board again for just drawing the different situations when C will be caused. All right, so we can have the poles coming in effect. We may have a situation like this. The compass is here. We can have a blue pole here. This is going to be plus B. Or we can have a red pole at this place. Or we can have a red pole here and blue pole here. What we are talking about here, that the rods are like this. Here we are talking the rods are like this. Here we are talking the rod is like this. One continuous rod having two poles. Here we are talking about two poles like this. So these are going to cause positive B. Why? Because the field has to be working towards the direction of the field has to be yes.
Athwartship horizontal.
Athwartship, horizontal, yes, these are the already rods are there. But the field, if it is acting towards the starboard, then positive. The field has to be working towards the starboard. So here in all these cases, the field will be acting towards from red to blue. Here, if this is the situation where there is pole like this, here also they are going like this. Is that correct or not? So
Yes, sir.
the direction is still this way. If it is like this, it is coming like this. Again, it is working towards the starboard. Correct?
Yes, sir.
So that is what we are saying. Here also, it is running in this direction. All this time, all these situations, the magnetic field is running towards the starboard and giving rise to plus B. This ulta situation will be there for minus B. चलिए fresh बना लेते हैं. So for minus B, you are going to have the poles that you are going to have is the blue pole here, blue pole here, and the blue pole, or only the red pole rather. Red. Okay, red, red, and this is the same. Seeing this again, if you see, the red pole will be at this end, red pole here. Since it is here, the blue pole will be at the other end, and here already there. Now these lines of forces will be going like this. So is it working towards port?
Yes, sir.
Yes, sir.
Here it is going like this. Is it working towards the port? Here it will be going like this. Is it working towards the port?
Yes, sir.
All right. So these are the situations of sorry, minus B क्यों लिखा है मैंने? प्लीज मेक करेक्शन. अगर मैंने मुझको लग रहा है कि मैंने पहले वाले में बी लिख दिया था ना.
Yes, sir. पिछले वाले में B लिखा है.
हाँ नहीं ऑल दैट इज सी. नाउ वी आर टॉकिंग अबाउट सी. और बी इतना बात कर रहे हैं पिछले 2 क्लास से 3 क्लास से कि बी वही दिमाग में आ रहा था. तो दिस सर वी आर टॉकिंग अबाउट सी. Most likely this will be the condition when there is this plus PC, basically this case minus PC and plus BC plus PC in the previous case. This is, we are talking about the Q force of the permanent magnet. Of course, there will be rods, as we have seen here. The soft iron rods also may be there. Various kind of situations where they will develop either plus C or minus C. We have already written down that C is the algebraic sum of permanent C and induced C. what we are saying is that if there is PC, permanent C, which is acting in this direction, and there is also a soft iron which is developing something like this. So either it adds up or subtracts to this. ये जितना होगा plus ये जितना होगा. इस case में it is going like this, so it is also like this. Overall effect of C will be the algebraic sum of this plus this. If we have a soft iron which is in opposite direction, then we will have this minus this, or whichever is bigger. क्योंकि यहाँ पे ये उल्टे डायरेक्शन में है, नहीं उल्टे डायरेक्शन में क्यों, यहाँ तो वही डायरेक्शन हो गया. क्या कर रहा हूँ मैं? What am I doing? हाँ नहीं ठीक है, ओके, ऑपोजिट डायरेक्शन में. All right. So permanent C, यहाँ पे हमने बात किया कि this was the Q force of the permanent magnet. You can also write down one line about the soft iron rods which are going to cause this C factor. टाइम हो गया, अच्छा टाइम हो ही गया, ज्यादा हो गया. ठीक है, अगले क्लास में करेंगे हम लोग, अगले क्लास में विल टेक इट फॉरवर्ड.
Okay, sir.
ठीक है, चलिए, टाइम हो गया, 5 मिनट ज्यादा हो गया. All right, have a great day all of you.
Thank you, sir. Good night.
Thank you.
Yes, good night. Signing off.